Hello, welcome to How Could We Make Human Missions to Titan Possible? This is webinar 3 in our series from Explore Titan. Thank you for joining us this afternoon. My name is Bill O'Hara. I'm the Executive Director of Explore Titan, and I'm very happy to have this discussion with you all today. We are recording so that we could post this webinar on our website and also want to improve. And later on, we were interested in more comments on how to make these better. My hope is to do these yearly as we gather more information and we can mature these presentations. So thank you again for joining, and we'll get started because there's quite a bit to talk about today. I'm going to enable the chat. So let me know if there's a problem with the webinar, if you can't hear me or any other issues. So we'll move on here. So a little bit of background, since if this is the first webinar you've tied into, Explore Titan is a nonprofit research, outreach, and advocacy group. We are sort of like a sister organization to Explore Mars. If you're more familiar with that organization, they are advocating for human missions to Mars, and we're exploring the idea of human missions to Titan. Sort of instead of Moon to Mars, maybe the next mantra is Mars to Titan. So also, like going to Mars, we have a lot still to learn, to prepare ourselves before sending people to Titan. And that's what we're all about. What are the hard problems to tackle? Who's working those? How could we work them harder, smarter? And so it's a lot of what we're all about. We're hoping to post more information on our website. You can explore at exploretitan.org with podcasts and more webinars and learning materials going forward. If you're interested in helping out Explore Titan, if there's something that's piqued your interest in either various activities, writing papers, fundraising, managing our social media, please reach out. You can reach out to me directly at executive-director@exploretitan.org or our generic email at info@exploretitan.org. So again, this is our third in a series. We've been building up each one of these. We started with why. Why is Titan a good destination? What would it be like to try to have a mission to Titan? What would it look like? And now we're going to cover how. We identified a lot of challenges in the last webinar, and we'll bring those back up again today, but focus on what are the options and ideas for overcoming some of those challenges. Obviously, we don't have all of the solutions for you, or else we'd be a lot further along in developing a mission. But let's talk about at least the ideas as they currently stand for how to overcome those challenges. So we're going to tackle that today. It's going to be a fun one. And then next time we'll talk about when. What are the things that we need to do and kind of a stepping stone approach before we can send humans to Titan? What would that kind of timeline look like? So we'll hit that in the next one. So again, in this webinar series, what to expect, hopefully informative, no matter what your incoming level of knowledge is. I'm not going to go deep into math or anything here. So hopefully everyone at all different backgrounds find it interesting. Definitely hoping to provide professional and constructive discussion, and please keep the chat the same. I will be using Slido to ask questions, so have your phones ready so you can scan the QR code and join in those questions. I'm interested in your input. Maybe you've got ideas that I haven't thought about. And then at the end, if we have time, certainly welcome to take questions in the chat. So we will be wrapping up at the hour mark to respect everyone's time. All right, let's start with, again, a review of what does NASA plan to do after Mars? And you may not have heard anything, you may not realize that there aren't discussions about where human exploration might go after Mars. And there's this one graphic that they did present in 2023 that at least keys us into knowing that they're thinking about it. You can see in the bottom right corner, after Mars, future destinations. Titan is one of those in consideration. There are other interesting places, but we're going to focus on Titan as a leading option. Don't know if NASA thinks that, but we are certainly hoping that we will gather enough information and make the case that Titan should be the next destination after Mars. So why recommend it? Just a review from our first webinar. Titan is an ideal next destination after Mars because it is a completely different kind of place, an ocean world, different from the terrestrial worlds we've been to, different than even Venus. an ocean world would be an exciting place to explore, to expand our knowledge of planetary science. It has a thick atmosphere that can protect us from radiation. A lot of other locations within the solar system are not very feasible because of the radiation levels involved. So Titan has a thick atmosphere that can mitigate that problem. We have an entirely new world to explore. If you do some research on Titan, you find that there are dunes, lakes, and rivers, and land. So it's a lot of varied terrain to explore, all existing on an ocean world. It has an ISRU potential like no other place. Liquid methane, hydrocarbons, water ice, and even plastic material called tholins that would be interesting to make use of. So it really would expand our ISRU capability, add to our repertoire, if you will, of what we do on the moon and Mars. And also the potential for harboring life. So certainly an interest in searching for that. So challenges. I'm going to try and move fast here to get right to the meat here because we do have a lot to cover. How can we overcome the challenges of human exploration of Titan? So we want to use the moon and Mars as stepping stones to Titan. So it's continuing that same kind of strategy that's currently in place for planetary, at least human planetary exploration. So how could human missions to Mars help missions to Titan? Well, there are a number of things that are going to carry over. And even backwards, once we go to Titan, there are going to be problems that we solve that will work backwards and improve lunar and Mars missions. But let's start with why Mars to Titan is a good idea. Oh, I'm going to jump back here. It's like we're jumping at our first Slido. So I'd like your thoughts on how missions to Mars can help missions to Titan. So if you could scan that QR code with your phone and give us your thoughts, and maybe you come up with some methods, some ways that I haven't thought of yet. Give you a moment to scan that and input your answer. You can do more than one. I think the first time takes a minute for everyone to get used to the process here. So happy to give it a couple of minutes. I see some folks are typing already, so that's great. I have these Slido questionnaires sprinkled throughout the presentation time. Sometimes they jump in and surprise me. Astronaut operations, yes. In what way? Maybe you could expand on that. And astronaut operations with what respect? What's more typing going on? Maybe not. Give it another minute. I don't have a written link. You can go to slido.com though and input that number. That's #3222601 to get to the question. Sustaining astronauts for long periods of time. Absolutely. Mars missions are much longer than anything we've had to do to date, or much longer than going to the moon as well. We'll give it another minute here. I see some more typing going on, and then we can move on. Again, ways that missions to Mars can help us with missions to Titan. There we go. Sustaining astronauts for long periods of time. Looks like some words got jumbled a bit there, unfortunately. Transfer, learning, effect, long astronauts. I think learning is a big one. That's what it's all about. Learning about landing and living on another planetary body, one that's much further away than the moon. Absolutely. That time delay, more independence from Earth, things like that we're going to learn a lot about going to Mars. do some more typing. I don't want to cut this off too early. So go ahead and finish your inputs. Oh, learning how long transfers affect astronauts. Yes, that long transit. We're going to jump into that a bit here. All right, thanks for the inputs. Yeah, you're right on target with what I'm thinking as well. So we're going to learn a lot about long duration spaceflight, far from Earth. Exactly. Large scale entry, descent, and landing. So landing not small rovers, but large habitats, large ISRU systems. That's a whole different business, especially on Mars with a thin atmosphere. Surface habitats in a foreign atmosphere and a surface. So a place with weather, something different than, different kind of weather at least, than what we find on the moon. So we have wind, for example, reliable and automated ISRU systems. So a lot of the plans for Mars involve ISRU, and some that have to operate without humans present for a long period of time. And surface EVA operations far from Earth. EVA operations on ISS, for example, are very well orchestrated. And on the moon, I think we're going to learn more about more independent EVA. But certainly on Mars, we're going to learn even more about allowing the crew to manage their EVA operations and their operations in general. So feel free to throw in any more that you think of in the chat. I'm happy to capture those as well. So let's take a look back at each segment of the mission to Titan, and we're going to break that down, look at the challenges, revisit some of these ways that how missions to Mars will help Titan, missions to Titan. So here we are with our mission to Titan, starting with Earth on the far left. So we have departure, Saturn transit, going to orbit around Saturn. Whether or not we go into orbit around Titan or direct to the surface is, a mission architecture question of analysis. We have entry, descent, and landing. So landing on Titan, and then the surface phase involve living and exploration on Titan. So each of these phases comes with its own specific challenges that need to be overcome. We do have a couple of precedences that we hope to have, one already and one in the near future. Cassini-Huygens. So Huygens is the lander that landed on Titan. And we have Dragonfly coming up and launching, I believe, in 2026. That's going to be an exciting mission to gather even more data. So these both will give us more information about getting to Titan and landing on Titan. So it's exciting lessons learned. Obviously, there's going to be a lot more I think we'll need to learn about Titan before sending humans. So how can we make it happen? First question, getting to Titan. So that long transit phase. We have a very long travel time. To date, Huygens and Dragonfly are looking at 6 to 7 years, and transit to Titan, so that's a very long time, much longer than getting to Mars, which you traditionally hear around 9 to 12 months-ish in getting to Mars. So look, with that long duration comes a whole host of challenges. Long duration effects of microgravity. That's already something being discussed for trips to Mars. Radiation exposure, how to keep the crew occupied for that long period of time. Reliability, dependability of the ship. That's a very long operational period, especially for round trip, if that's going to be on the order of 12 to 14 years plus. And then the quantity of consumables needed. So these are all challenges that are obvious when discussing the transit time to Mars. So we see two classes really of ways to address this challenge. First one is to accommodate the long travel time, deal with it, figure out ways to just live with having a long transit time. And then the other is to shorten the travel time to something that's much more manageable. So we're going to discuss each one of those. And again, I'm going to be getting you some of your input as well. So how could we overcome the challenge of extremely long transit time? So this is if drastically shortening it to something that's acceptable is not an option. How would you just deal with long transit time? Maybe you could get it down to 4, 5, 6 years, but still these are long travel times. So what are the ideas for overcoming it, just dealing with a long transit time? Glad to see we're moving faster. Everyone's got the groove here. People are already typing. Got those brain cells going. I know here it's Friday afternoon, maybe Friday evening for folks. Short-term hibernation. Exactly. Yeah, that is I think something that would have to be explored. Absolutely. We're gonna talk about that as well. So that's a good first input. This is kind of a hard question, so appreciate the typing. Auto-sufficient ships. So yeah, I think what you mean is, autonomous ships, so that the crew doesn't have to do a lot with the ship to get there. Think of your 2010, 2001 Odyssey, where you've got AI controlled ship. I think a lot of that's going to be needed versus the much more involved operation that we have with the International Space Station. Cryogenization, I think you mean, again, that sort of hibernation capability, cryosleep. We've seen that in lots of science fiction stories. Generational crews and families, ships as a village. I don't think we're quite that long, but it's you're maybe broaching on that level of duration and what we might explore for preparing us to go out of the solar system as well. All right, good. So this is a tough question. Let's break it down a little more. Feel free to please give more inputs in the chat, so I make sure I capture them. So let's talk about dealing with long travel time. One of the first that I've listed here is artificial gravity, already being discussed for Mars missions. The long duration exposure to microgravity is a real challenge, right? You want the crew functional back into a gravity environment when they get to their destination. You can't have them turn to jelly on the way. So artificial gravity is something that could be very important for a long duration trip to Titan and even to Mars. So I've listed some papers in here, and I have a full list of references at the end that you can take a picture of. Certainly, there are a lot of references regarding artificial gravity. It's been discussed for a long time, but I think it could be something very important and something that might already be explored for Mars missions. So we'll be able to take benefit of that. Induced torpor, or the hibernation system capability. Torpor state is more the medical term, but there's various versions of this. A good summary from She talks about these options. It's been explored since the 1950s, and you can find a number of papers out there talk about the options for doing this. Obviously, that comes with its host of challenges and issues. The recent movie out there called Slingshot, that was about a mission to Titan, explored the idea of hibernation capability. So that addresses the problem with boredom and a long wait. You're going to sleep most of the trip. And I think this is especially beneficial on the return trip to avoid the third quarter syndrome. So that's the effect of coming back from a long mission and realizing you have a long trip back, and the crew, without the destination to look forward to, without Titan to look forward to, there's a psychological challenge called the third quarter syndrome that they're exposed to on that second half of the mission. Radiation shielding is another one. So long duration radiation exposure is something that is already a challenge for going to Mars. Long duration trip to Titan is going to make it even worse. So how do you address that? Well, we're going to have benefits for the Mars missions. We're going to be thinking about that for going to Mars. If you couple that with torpor state or hibernation, then you can then keep the crew in a well protected small area of the ship and have extra shielding there to address this problem. So those two kind of work hand in hand if you're able to do both. So artificial gravity, endorsed torpor state, radiation shielding start to address your some of those challenges. Consumables. Let me get that. Except a typo. Inflatable large amount of storage. I I think what we're talking about there is inflatable modules that act as large stowage modules that then can be decompressed, maybe even detached as you empty them out, so you no longer need them. Growing food in greenhouse modules, some already discussed for the moon and Mars, but it could be done if the crew is awake to do that, or if it's done by robotic means. And water recycling, already proven on ISS at about 99% recovery rate, and something planned for Moon and Mars as well. So it doesn't exactly eliminate the challenge of consumables. Again, if you're coupled with a torpor state, then your consumables rate is different for that kind of mission. So these methods here can at least help alleviate it some. And design of the spacecraft. I think reliability, dependability of the spacecraft is something that's we're gonna see a drastic increase in attention to on Mars missions. Even for 6 to 9 months or 12 months, you need a very reliable spacecraft, and that's going to be well tested. And we could also use multiple copies, use increased redundancy and reduce costs. So what if, instead of one spacecraft, it was 2 or 3 of them joined together, and you could use another one as a safe haven in the event that one of them has a failure. So ways of accommodating redundancy and fault tolerance while trying to keep reduced costs are going to be important. And I think, again, some of these we're going to explore in Mars missions. So dealing with it is still a real challenge. I think the preferable approach, you might all agree, is to shorten the travel time instead, to get it down to something more reasonable than trying to deal with a 6 year to 7 year travel time. So what would you think are the leading options for shortening the travel time to Titan? What could we use? I think this should scroll. So I've got listed here wormholes, nuclear propulsion, solar sails, LOX hydrogen engines, electromagnetic railgun, solar-powered electric propulsion. So some options out there. Maybe you think of others. You can put those in the chat. But do you think one of these is the leading option for going to Titan? I don't think we have a whole lot of folks online today, but interested in everyone's input. Nuclear propulsion is the leading option here. Any others care to weigh in? If not a propulsion expert, that's good. That's just fine too. Electromagnetic railgun. We'll have to explore that one some more. All right. Let's go on. This looks like inputs on nuclear propulsion, electromagnetic railgun. I am going to talk. Well, let's see. One more question here before we move on. This is more of your opinion. What is a reasonable amount of time for getting to Titan? Do we need to get there in 3 months, 6 months, 9 months, 1 year, 1.5, 2 years, 3 years, 4 years? What is a reasonable transit time in your mind? Maybe put yourself in the position of a crew member. 1 year, 1.5 year? Yeah, I think you're along the lines of what I was thinking as well. I think that's if we could work the problem to get down to 1 to 1.5 years, then we've made it much more achievable. I think if you could try to continue working the problem to get it down to less, but the question is, do you really need to? Or are you just making your life a lot harder? So, shortening the travel time, you're right on the dot with one option, nuclear propulsion systems. That's been in development. Very high ISP systems, so it generates a lot more thrust per unit mass of propellant. Essentially has an inherent heat source that is capitalized in both of these options. A lot of work being done on nuclear electric and nuclear thermal. So nuclear electric generates electricity to accelerate a gas out of a nozzle. Typically, xenon is one of the propellants being used. Nuclear thermal directly heats propellant, out of the nozzle, and hydrogen is propellant. It's discussed a lot, and a lot of works out there. And again, I've got more references at the end. There's been a lot of research into both of these, and in these studies, they've been shown to feasible to get the trip to Mars down to about 200 days for a round trip versus around 540 plus days that we're normally used to thinking of. So a drastic reduction in travel time to Mars. So the question is, what could nuclear propulsion do for you and trips to Titan? I'm involved in a research project right now where we've simply asked the question, what would a nuclear propulsion system look like to get the travel time to Titan down to a year? I'm glad to see if other folks thought a year was reasonable. So I've asked that question of a year, and we're working on a concept that would answer that question, see what it looks like. So getting to the surface of Titan, moving on to the next phase here. Now that we've gotten to the Saturnian system, we've gotten in orbit around Titan, maybe we're leaving part of the spacecraft, the transit spacecraft, in orbit around Titan. Now let's talk about getting down to the surface. Yeah, Roger, any more than a year, psychologically challenging. I think that's a lot of Mars mission analyses has indicated that that's an awfully long period of time. Don't disagree with you. Getting to the surface of Titan. So the challenges. Um, if you dig into some of what Huygens learned about Titan, there's high wind speeds in the upper atmosphere. The atmosphere is quite thick, and it has weather. It has rain, methane rain. It has clouds. It can have storms. This isn't like Earth where we have an accurate atmosphere model. It's taken us years to even understand Mars. And the issue of fuel that's needed for all phases of the mission really is still a question. So with those challenges in mind, what are the options of overcoming them? What can we do? What can we prepare for? So fortunately, we have some precedents on re-entering an atmosphere, both on for the Earth, for going to Mars. We have various ways that have been tested with heat shields and parachutes and airbags, or landing on wheels, water landing. We do have lakes of methane, so technically you might try to land in one of those. So we have a lot of experience already to date and landing in various ways, which is a great toolbox to pull from. Specifically for Mars, parachutes and airbags and the sky crane have been used. So we could explore each one of these for landing on Titan. And obviously, by the time you're getting to Titan missions, presumably we've already got humans going to Mars. And so large-scale landings on Mars, we figured out how to land those on Mars, and all that body of work it would be available for developing a mission to Titan as well. So a lot of precursor work, what we've already gathered and what we're still going to learn about going to Mars is going to help us in getting through the atmosphere of Titan and landing. I think we'll touch on more on precursor missions as well, especially in the next webinar. So what questions do we need to get answered using precursor missions? And I think that the weather on Titan is going to be a big one, and understanding the atmosphere a lot more, understanding weather patterns, the wind patterns, so that we can build a model and accurately do a descent and landing on Titan to a predestined point of interest. So that's where precursor missions, I think, are going to be very important. So yeah, I kind of got ahead of myself on the next slide. So precursor robotic missions are going to be very important in this phase, and understanding the atmosphere so that we can do an accurate descent and landing. Hazard avoidance systems. A lot of work has been done for Lunar and Mars on coming in for a detailed landing and not landing on a big boulder, not landing in a crater, not landing in a methane lake. Is going to be part of the hazard avoidance for Titan. I think one of the great things about Titan is that thick atmosphere. It's both maybe a challenge, but also a benefit. You have low gravity, a thick atmosphere, So a lot of systems will work well. Aero capture, aero braking, I think are going to be options to explore even more with Titan than with Mars. Airbags and parachutes, even gliding and power flight. We have a thick atmosphere and low gravity. Flight is going to be a much easier uh, task than it would be for Mars. So I think you could even come in and parachute and glide. You can combine some of these on Mars. So let's let that thick atmosphere work to our advantage. It will be things to explore for landing on Titan. So now we've landed on Titan. We are cruising along here. I'm going a lot faster. I think we've got a few more Slido questions, so that'll take some time here. But hopefully, if we do finish up early, we've got time for some Q&A. I see some comments in the chat, so we'll be able to hit those. So living on the surface of Titan. So now that we've gotten there, we've landed, how could you live on a place that's this cold, this far away from Earth? So the challenges that we brought up in the last webinar were the extreme cold. You're at cryogenic temperatures on the surface of Titan. So we really got to think about material choices and thermal control. We have long nights. This is going to be a little deja vu from going to the moon. But here we've got 8 days of night and 8 days of daylight. So a 16 Earth day day cycle on Titan. Long duration delayed communication. So much longer than going to Mars. We're over 2 hours in round trip travel time for communications from Titan. So you're going to be much more independent. You have ice that's available, so there is water, but at this temperature, it's like rock. So it takes a lot of energy to harvest that water ice and to use it, even more so than what we'd find on Mars. And you're at a much dimmer amount of light. So you get 1/100th of the amount of sunlight reaching Titan than you have reaching Earth. So solar power, while still possible, will require much larger arrays or much more efficient arrays. So a lot of challenges with living on the surface. I'm sure there are more. And we're going to learn in precursor missions what those are. Oh, looks like my chart on the right didn't turn out too well in here. But I wanted to focus just for a minute on power generation topics. So there was one paper done already in 2017, Amanda Hendricks, and folks looked at options for power generation on the surface of Titan that might benefit human exploration. And they looked at a number of options in there. It's a really good paper if you get a chance to read it. They looked at combustion of methane, probably one of the most immediate things you think of with an atmosphere with a fair amount of methane and liquid methane available. So how could you burn it? Well, part of the challenge is there's no oxygen, no free oxygen on Titan. So you'd have to extract the oxygen from in situ water. Sorry for another typo there. So electrolyze, extract the ice, melt it, electrolyze the water to get oxygen. Hydrogenation of acetylene. Acetylene is available from the atmosphere, so is hydrogen. So you could hydrogenate acetylene, which is another exothermal reaction. Hydropower or what you might need a better word than hydropower, but using lakes and rivers to generate electrical power, just like we do here on Earth, could be an option. Wind power on the surface of Titan. The winds, from what we know so far, are most of the time very gentle, but high in the atmosphere, you have some high wind speeds, so maybe some floating wind power generation systems could be of benefit. And solar power, still an option. You just need to increase the size and the efficiency of the solar arrays. And so it was a really good paper that evaluated those options. And one of the things it points out, at least, is that in the beginning, you're going to probably bring nuclear power from Earth. And you might also need that nuclear power as the catalyst for choosing something like combustion of methane, where you're using nuclear power to extract the water and to electrolyze it, store it for later use in combustion with methane. So still options there. So at least a little bit of work done on assessing power options for human exploration of Titan. And to me, this is an exciting area of additional research. So hopefully folks will pick up the thread and do more. So more on living on the surface. So here, lunar and Mars missions are going to help us out a lot. Uh, on the moon, you're probably familiar with the very cold regions and the permanently shadowed areas. And that's a real challenging area to work in. And I think we're going to tackle that problem someday. So working in very cold environments will be part of our lunar exploration program. And a whole host of these planetary protection measures. We're going to learn about doing that for Mars, and we're going to apply that to going to the moon or going to Titan. We're going to learn about living on the moon, what it means to have long duration day and night when you're in equatorial regions, surface EVAs on another body, doing sorties by rover, so driving around for long duration periods on another planetary body, the communication delays, surface habitat systems, being more independent from Earth, and nuclear power. These are all things we're going to learn when we're going to the moon, especially going to Mars. So all this will have forward effect in our Mars to Titan strategy. Additionally, we have still the option, just like we do for Moon and Mars, of terrestrial analog testing. So Arctic conditions, again, being very cold conditions, very austere, we could find ways of using the Arctic and subsurface water vessels. So the surface pressure of Titan is about 1.5 ATM, so about the equivalent of the deep end of a swimming pool. So we could, again, put habitats underwater and learn more about the aspect of living on Titan that involves being in an elevated atmospheric pressure. And laboratory materials and systems testing. So you're going to find, if you dig into like development of the Dragonfly spacecraft, they're doing a lot of laboratory testing with materials to understand what works and what doesn't work in that environment. So we'll be able to harness that for the materials that we need to build habitats for Titan. So on that question of materials, do you know of any materials that work well at cryogenic temperatures? So this is maybe a question that folks aren't too familiar with, but maybe you are. Do you know of any materials that work well at very cold temperatures? Think things that are in contact with liquid nitrogen, liquid methane, liquid oxygen. What do you know of that can be used? To me, this is one of the main challenges with living on Titan. Is going to be material choices, being at that very cold temperature. Glasses and ceramics. It's interesting. I hadn't had that one in my list, I don't think. We'll look in a moment. I'd like to hear more about that one. Copper alloys. Okay. If you have any references on some of these, I'd love to hear more about them. Aluminum. Potentials that solidify. Yeah, I'd love to hear if anyone out there has some experience with these or knows of some references and work done on these materials. Love to hear more about it. So some that from our research that has been found to work well. This is from at least from one work out there. Kallio summarizes a lot of materials that work well at cryogenic temperatures. So at least in propulsion systems that deal with like liquid hydrogen, Teflon or PTFE works well in that system. You capture aluminum, but also and copper. So we saw those two, steel and brass, other metals that work well. Polystyrene, polyurethane, polyvinyl chloride or PVC. So some of these are more flexible materials, which is going to be necessary. Kevlar, another high strength material, actually increases strength with tensile strength with lower temperatures. I think that could be an important material choice in Gore-Tex as well. These are at least the list that I grabbed. There may be more out there. I think we'll need to build a database of materials and their properties at these low temperatures so that we know what our toolbox is for designing habitats and EVA systems, landing systems, rovers. So material choice is going to be very important in this kind of environment. And some of these will probably be tested on the moon and Mars. So that will expand our level of knowledge. So very good. So I think this is a key area of additional research. So we've traveled, we've landed, and now we're living there, but that's not the full point. Our goal is to explore the surface of Titan. So let's review the challenges there and some options for overcoming them. So now we want to get out of the habitat and go explore. So there are several options. We brought these up in the last webinar, but EVA is an obvious one, getting out and walking around. You have 1.5 ATM atmospheric pressure, so suits are going to be different in a way that could be simpler than your traditional space suit. We'll talk about at least a little bit of work that's been done in that area. I think some more challenges with a low light level, and what we saw from the images with Huygens are the dim, almost monochrome lighting, kind of orange lighting. That would be a different thing to get used to. And the extreme cold, methane rain and mist, the nitrogen atmosphere, 95% nitrogen. So these present challenges for an EVA suit. Wheeled and tracked vehicles, a very common use for the moon and Mars and trying to explore those locations. I'm sure we're going to want that capability for Titan. So we've got some different challenges. The surface consistency of Titan is not well understood. We have one data point from the Huygens landing, and it described it as a kind of a crunchy surface with a wet sand texture underneath. So that doesn't sound too promising for a wheeled vehicle. Maybe some new wheel designs, but that could be an interesting area of development for precursor missions to try to land a rover, see what works well on the surface of Titan. And airborne. Certainly we're going to learn a lot more from Dragonfly because of the dense atmosphere and low gravity. Flight is a very achievable capability. Maybe you could have helicopters or gliders for humans to help them get around on Titan and cover long distances. But I think here again, we're going to need to know more about the weather patterns to make it safe. What it means if it were to start raining methane when you're out in a helicopter or an aircraft. We may learn a lot of this from the Dragonfly mission and other precursor missions, but we're going to need to answer these questions before we tell the crew to start flying around in a helicopter on Titan. Drones and sea rivercraft. So certainly drones, Dragonfly is going to answer a lot of that, a lot of similar challenges to flight and sea and rivercraft. So if you want to make use of the methane lakes and rivers for transportation, that sounds very interesting. I hope to see a sailboat on Titan someday, but a lot of questions to answer on what that would look like. What you might use a Zodiac or other kind of power boat to get from point A to B on Titan. And what would that boat look like? Something designed to travel through liquid methane would be quite interesting design challenge to hit. Certainly some unknowns there, but maybe some of these could be tested in a lab. So it'll be interesting to see. So how could we overcome some of these challenges? I've hit on some things. Maybe you can think of more. These are modes of travel, modes of exploration, and I've listed the challenges with them. How could we overcome some of these? Maybe I've already given that away too much because I like to talk a lot. So I'll give it a minute here. See if you can think of some things that I haven't thought of that are going to be needed to help us explore the surface of Titan, make it safe, make it feasible. A lot of comments, which is great. I'm going to capture all of these comments. Simulants of Titan regolith, explore interaction. That's a good one. The question would be, would we want to include a sample return mission as a precursor to sending humans? That's a big mission. It's already challenging enough for Mars. Could you imagine it for Titan? So is that, we'll have to ask ourselves, is that required? Can we gain enough from robotic missions to answer the questions that we have to mitigate the challenges of the regolith consistency? Oh, Carlos has a great, it's a good deal. So that's it. Liquid methane proof materials. Yeah, I think it's going to be a pretty robust testing program. Be interested to see more of the work coming out of the Dragonfly program on or drones on Mars. When you're exploring a new location, we have this question for the Moon and Mars. I'm going to have it on Titan. You land in one location, and if that's all you get to explore is maybe that one location with a short distance away and an EVA, is that enough? Imagine landing on Earth and getting only to explore one, small town, right? Is that enough? So things like airborne capability, mobility, so that we can reach further and further away and look at other interesting locations on Mars. The more benefit you can get from the single mission to Titan in terms of extent of exploration, that's just more return on investment. So I think airborne will be an important option to consider. I'm thinking of 2 EVA crew members and a small foldable helicopter. So I've got typing, so we'll let one more input in and then we'll move on. Exploration tools and planning. Yeah, the crew's gonna be much more independent. We're gonna move along that spectrum with Mars missions, right? But with Titan, it's gonna be even more distinct. How to be more independent, planning their own mission, their own days to achieve their own goals, or at least achieving a predetermined set of goals. Drilling equipment. Yeah, drilling into ice at this temperature, that's something I think is going to need some testing. If we're going to incorporate ISRE capability, how you drill and extract that water is going to be some systems that need to be developed. Maybe tested on a precursor mission with another lander. We've done that with Mars. We tried to drill into the subsurface. So it might be have to be included on another precursor robotic mission to Titan. We're adding to that list. It's going to be a long list of goals for precursor missions. All right, so ways to overcome. I think we've covered some of this, but I've got it here, so we'll go over it. Lunar to Mars experience. So Titan analogs on the Moon and Mars. We're already asking for how can we do analogs in low Earth orbit or on the Moon to prepare us for missions to Mars, so analogs to Mars. We'll be asking that same question for Titan. What are analogous locations on the Moon or Mars that can help us answer questions for Titan? Exploration and permanently shadowed regions on the Moon, I think, are one of them. Very cold locations where there's frozen water that we want to extract. That starts to sound like goals for Titan as well. Terrestrial analog testing. I've mentioned Arctic, Antarctic. So are there some regions there that can help us not fully emulate, of course, the surface of Titan, but as we break apart these challenges one at a time, are there some of the questions that we can answer for using Arctic and Antarctic as analog test sites. I think underwater is still one, since you can mimic the surface pressure. So we might want to test out EVA systems, test out the airlock system underwater. So we have that added similar pressure. So these are things I think we'll need to investigate to help answer these questions and mitigate the problems we're going to Titan. And we've already hit on precursor missions. I think it's going to be big, just like we're using for Mars. We're going to need a series of precursor missions with predefined goals to answer the questions that we have to prepare us for going to Titan. So really extending the same strategy that we're using for Mars. EVA on Titan. So this is a very interesting one. We don't have a vacuum or near vacuum like you have for the Moon and Mars. You have a good atmosphere here. It's 1.5 ATM. So do you need a pressurized EVA suit and all the challenges that come with the pressurized EVA suit that we're constantly dealing with for the Moon and Mars? Or do you need something different? So I'm glad to see at least one toe dipped into this question with DeJoux and Lee just this year, published a small paper on Titan EVA suit concept. I think this could be an area of a lot more exciting research. But in their work, they derived a concept from a hazmat suit. So you will protected from the atmosphere. They devised a self-contained breathing apparatus. They split the suit into multiple layers with sort of like you have for a spacesuit. So it's extending some of that knowledge with an undersuit system for thermal regulation. So heating up rather than cooling probably. A full face mask, nitrox breathing system, so you can't expose your skin to the atmosphere of Titan for sure. And an outer suit that has additional thermal and chemical barrier to it, and then a flexible fabric shell just to on the outer side of it. So these things are going to get dirty on this as you're doing EVAs. You're going to hit a lot of rocks, a lot of same kind of abuse that we'll see on the Moon and Mars, but at different temperatures. So the materials will need to be different. So DeJoux and Lee looked at this problem, came up with some concepts for how to overcome them. Really exciting to see someone taking a look at this. I think this is an area that a lot of folks could look at in more depth, and we could develop some concepts and do some testing. So at least a little bit done in this area for EVA on Titan. I think that's going to be very important for enabling our crews to explore the surface. So we've traveled to Titan and discussed all the challenges and some ways to overcome them. We've landed, discussed the challenges of doing that and some ways to overcome it. And we've lived on Titan, we've explored and talked about those challenges and some options to overcome them. We don't have all the answers. We have a lot more questions, but a plan could be developed for answering these questions, just like we do for missions to Mars. So it's certainly, as you break apart the problem, maybe if you thought it was a very outlandish idea to start with, hopefully maybe it's a little less outlandish of an idea of humans going to Titan. It's kind of our hope in reviewing all of this and having this webinar. So we've only skimmed over a lot of ideas. This was a lot of information. We've only touched on solutions that could use a lot more research. I think that the key takeaway here, though, is that there's ideas to overcome some of these problems, and a lot of them will come from the Lunar and Mars. So capitalizing on everything that we do in those earlier destinations and now extending them to the next destination of Titan is really the philosophy we could use. So I think that's we've covered all the bullets here, but hopefully you came away with the right takeaway. The next time we meet, next webinar, we're going to talk about when. I really hesitate to try to pick dates, like a goal of 2100 or 2150. What we're going to talk about more is the precursor missions. What do we need to know? How could we answer those questions in a timeline kind of fashion? And if you do a hypothetical stack up of chain of events, we need to go back to the Moon, we need to go to Mars, We need to send precursor missions. What does all that mean in terms of when humans could go to Titan? That's an exciting question, hypothetically speaking, to think about. And you put Titan on the map, and now you attach maybe a time range to, and suddenly it becomes even more real, right? So we're gonna tackle that question in the next webinar. So I'll let me go. So we have about 5 minutes left. Maybe head over to the messages over here and see what we have. See any questions that we were posed that we didn't answer. So let's see. Sustain long periods of microgravity. Oh, cryogenization. Let's see. Food, water consumables, oxygen, waste. Active radiation shielding could be more interest. I don't disagree. Yeah, or at least deflecting radiation particles around your spacecraft. I think that's an exciting area of research. People looked at how you might use that capability on the moon, but maybe it's more feasible for around the spacecraft. You just need a lot of power, right? So, but I think that would be an exciting area. I should have included that. Yeah, active radiation protection is a good idea. I'm scrolling through. Comment about Mars also helping with the low light level. Yeah, certainly less on Mars. Routes to getting to Titan. Yeah, so the currently what Huygens or Cassini and what Dragonfly are relying on are gravity assists around Venus, around Earth, around Jupiter. So those have all been used in the past. As you try to accelerate your trip to Titan and increase your speed, question will become: would those trajectories still use gravity assists or not? I think it's a whole new level of a trajectory design when you try to rapidly or greatly increase your velocity. Planetary protection. Yeah, I think this is something we're going to have to do a lot of work on. With we're going the work done on Mars helps answer the question. So some different aspects of Titan that we're going to need to address on planetary protection and understanding potential for existence of life. So I didn't address that here really I don't think too closely, but I think that's an area of challenges that we need to do more work on is planetary protection in the context of going to Titan. No, I have not heard of any. There's a question about Titan regolith simulants. No, I don't believe anybody has tried. I don't know if we know enough about the surface of Titan to even develop a simulant. We only have some information about its properties based on the probes that are on the bottom of the Huygens lander. I think we're going to learn a lot more from Dragonfly, so stay tuned. It's going to be a number of years away, but maybe we'll learn enough from that mission to start generating simulants. It's a great question. Oxygen leaks from the suit. Yeah, so, and the potential for sparks and fire. So, yeah, obviously, if you have oxygen, the presence of appreciable amounts of methane, gaseous methane, then you could have an ignition problem or at least a combustion challenge. Fortunately, the atmosphere on Titan is 95% nitrogen, so built-in fire suppressant, if you will, and the rest is some gaseous methane and other materials. Caverns, emulating light inside of caverns. That's an interesting question. Yeah, you use caves and emulate the lighting. the amount of light that you would have on Titan. It's a good area to explore as well. So we're at 4 o'clock. I'm going to capture all these comments. I think I got all the questions. And the recordings of these webinars are on exploretitan.org. You can navigate to them from there on our events page. So the previous two are there, and I'll have this one posted hopefully by the end of the weekend. So really appreciate everyone joining today, and thank you for your inputs with the silo questions, and thank you for your comments and chat. Really appreciate it. And stay tuned for webinar number 4. Thank you very much.